Covenant University anthem. Thank you very much. You may please be seated. At this 30th Inaugural Lecture of Covenant University, it is my privilege to establish the protocols of this event. The Chancellor and the Chairman Board of Regents of Covenant University, Dr. David Oyedepo, the Pro-Chancellor, Bishop David Abioye, the Secretary, Board of Regents, Pastor David Oyedepo Jr., the Vice-Chancellor, Professor Abiodun Adebayo, the Deputy Vice-Chancellor, Professor Olujide Adekeye, the Registrar, Mrs. Regina Toby-Davids, the Royal Highness here present, other principal officers of the university, members of the Senate of Covenant University, faculty and staff of Covenant University, distinguished guests, members of the press, distinguished ladies and gentlemen. I have the honor and privilege today to bring up the Registrar of Covenant University to bring a word of welcome and introduce the key officers on the high table today. Please, would you put your hands together as I welcome Mrs. Regina Toby-Davids.
Thank you, the band. The Chancellor, sir. The Chancellor, sir, kindly permit me to stand on the already established protocol as I welcome our distinguished guests to the 30th Inaugural Lecture of Covenant University. I thought you'd put your hands together. This is a great feat for us because we just turned 21 on 21st of October, 2023. And in just that short period of time, we are having our 30th Inaugural Lecture. So I want to welcome this audience to this Inaugural Lecture. Right now, I'm going to introduce members of management and the community seated in this place on the high table. At my far left, we have the chaplain of Covenant University, Pastor Ola Judas. Thank you. Seated next to him is the Dean of Student Affairs, Mrs. Shola Koka. And next to her is the Director of Financial Services, Pastor Bolu Joko. Our hands together. And next to him is the Director of our Center for Learning Resources, Dr. Ada Peter. I will skip the inaugural lecture. To this side of the table, my right-hand side, we have the Dean of the College of Technology, Professor Timothy Anake. Next to him, representing the Dean of College of Engineering is Professor Ohanke. Next to him is the Dean of the College of Management and Social Sciences, Professor Roland Wallu. And next to him is representing the Dean, College of Leadership and Development Studies, Professor Abiodun Geshinde. And next to him is the Dean of the School of Postgraduate Studies, Professor Akan Williams. Next to him on the table is our Deputy Vice Chancellor, Professor Olujide Adekeye. And next to him is our amiable Vice Chancellor, Professor Abiodun H. Adebayo. And seated at the table today, representing the Chancellor and Chairman, Board of Regents of Covenant University, Dr. David Oyedepo, is a member of Regents, Pastor Niyi Bricroft. It's on this note, I warmly welcome you once again to the 30th Inaugural Lecture of Covenant University. You are most welcome.
Thank you very much. Please would you put your hands together again for the Registrar of Covenant University. At this point, to bring up a welcome remark, please put your hands together as I welcome the Vice Chancellor of Covenant University, Professor Abiodun H. Adebayo. Please would you put your hands together to receive the Vice Chancellor.
The Chancellor, sir. Please permit me to stand on the already well-established protocol as I bring forth the remark of the Vice Chancellor at the 30th Inaugural Lecture of Covenant University. I warmly welcome you to this inaugural lecture, the 30th in our inaugural lecture series titled Sustainable Energy and Production Technology, Panacea for the Development We Want. We are delighted to present another topical lecture that addresses a fundamental aspect of our national life and sustainable development, economic development. This 30th inaugural lecture topic is very germane and timely, coming on the heels of global outcries on the effect of greenhouse emissions on climate change. Study has shown that fossil fuels such as coal, oil, gas are by far the largest contributors to global climate change, accounting for over 75% of global greenhouse gas emission and nearly 90% of all carbon dioxide emissions. The effect of greenhouse gas emission is quite horrendous. The world is now warming faster than at any point in the recorded history. This has led to severe storm, hotter temperature, increased drought, exacerbating water shortage, global rise in hunger and poor nutrition, and increased health risk. Recent research findings released by the World Health Organization project that between 2030 and 2050, climate change is expected to cause approximately 250,000 additional deaths per year from undernutrition, malaria, diarrhea, and heat stress alone. It further states that from 1990 to 2019, the total warming effect from greenhouse gases added by humans to the Earth's atmosphere increased by 45%. The report noted that the warming effect associated with carbon dioxide alone is increased by 36%. Also, according to the International Energy Association, Nigerians' greenhouse gas emission, that is GHG, increased by 271.6% between 1990 and 2018. It added that Nigeria produced the third highest amount of this GHG in Africa, barely behind South Africa, Zambia, and in 2016, the country was solely responsible for 0.97% of the total greenhouse gas emission in the world. As Nigerians' greenhouse gas emissions continue to rise with its attendant environmental and health challenges, the cost of energy generation, distribution, and consumption continues to increase. For instance, in the current multi-year tariff order 2022, that is the MITO 2022, as approved by the Nigerian Electricity Regulatory Commission, NERC, to run from 2022 to 2026, consumers who were paying about 16 naira per kilowatt per energy in 2015 now pay about 55 naira, while maximum demand customers under Band A, who were expected to enjoy electricity for 20 hours per day, and paying about 71 naira to 80 naira for 1 kilowatt per hour. Despite the high cost of electricity in Nigeria, a large number of the population remained in darkness without access to electricity. According to the International Energy Agency, IEA, more than 140 million do not have access to energy in Nigeria, which is about 71% of the country's population. This inaccessibility to energy has also impacted adversely on the industrial development of the country and exacerbated poverty, economic growth decline, poor health services, poor research, development, and socio-economic imbalance. Addressing this power grid issue as the population grows rapidly remains one of the challenges the government faces to ensure the economic development of the nation. As a country with a fast-growing population with high demand for energy, scaling the energy sector is key to unlocking the nation's economic development. Solar, mini-grids, and off-grid technology could help address Nigerians' energy challenges. In 2017, the government made a climate pledge and set a goal to achieve universal energy access by 2030 and reduce the greenhouse gas emissions by 20%. Whether this goal, which involves the installation of 13,000 megawatts of solar power, is realizable or not, only time will tell. I have no doubt that this lecture will point towards a viable energy mix and production technology for sustainable development of our nation and continent. As a university, we remain committed to promoting research efforts to evolving innovative solutions to facilitate the achievement of the United Nations Sustainable Development Goals. Our efforts as a university in providing affordable, reliable, and clean energy, which is in alignment with SDG 7, has earned the university top 80 globally, where Covenant was ranked 79 at the 2023 Times Higher Education Impact Ranking of Universities. Maybe some of us did not understand. We say Covenant is ranked top 80 globally, 79 globally, in terms of clean energy, affordable energy, and sustainable energy. To God alone be all the glory. It is our hope that the shared knowledge and recommendations at this 30th Inaugural Lecture will prompt all the key stakeholders in the energy sector to begin to take actionable steps towards harnessing the country's abundant green resources to generate cleaner, cheaper, accessible, sustainable energy. Covenant is committed to green research in the areas of science, technology, which includes green and innovative energy solution. As I bring these remarks to a close, I wish to congratulate the inaugural lecturer for this milestone in his academic career and his outstanding contributions to knowledge in the area of sustainable energy and production engineering. Let me once again welcome you to this inaugural lecture for today. I'd like to appreciate every one of you who have come far and near to be part of this lecture today. Once again, thank you for coming, and God bless you.
Please would you put your hands together for the Vice Chancellor again? So the Vice Chancellor has raised some critical issues and pointed us in a direction. So I believe he has whet our appetite to look forward to the presentation today. Now, in the world of abundance of misinformation and oversaturation of information, when you're about to listen to a lecture such as this, you want to be sure that the person that is speaking to you is competent and knows what he's talking about. In a moment, we will be listening to a citation of the person that will be speaking for you to know that we are mostly honored to listen to an erudite scholar profess today. To bring the citation of our lecturer today, please would you put your hands together as I invite Dr. Omotosho Olugbenga to please come and bring the citation. Please put your hands together.
The Chancellor, sir, permit me to stand on already established protocols. May I respectfully invite the lecturer for today to stand up and remain standing while I read the citation. A brief citation of Professor Oluseyi O. Ajayi. Oluseyi O. Ajayi is a professor of mechanical engineering at Covenant University in Nigeria. He completed his undergraduate studies at Obafemi Awolowo University in 1999, followed by a master's degree from the University of Nigeria in 2004. He later obtained his PhD in mechanical engineering, focusing on energy systems and renewable energy from Covenant University in 2011. His research interests encompasses energy systems and design production technology, leading to significant contributions in renewable energy, material failure analysis, production technology, and nanoparticle applications. With over 200 publications in esteemed journals, conference proceedings, and book chapters, he serves as a reviewer for renowned international journals such as Energy and Renewable and Sustainable Energy Reviews. Professor Oluseyi O. Ajayi has extensive experience in university teaching, research, and administration. He has taught and supervised students at both undergraduate and postgraduate levels, producing numerous graduates, including 5 PhDs. Currently, he serves as an external examiner and assessor for various institutions, including Ladoke Akintola University of Technology, Tshwane University of Technology in South Africa, University of Johannesburg, also in South Africa, National Research Foundation in South Africa, Namibia University of Science and Technology, Federal University of Technology, Mina, and several others. Administratively, he is a former head of the Mechanical Engineering Department of Covenant University. He has served the university community on several platforms, both as member and chair of many committees, which include curriculum, accreditation, Covenant University Center for Lifelong Learning, college quality and academic standards, and university postgraduate boards. He currently serves as the chair of the Covenant University's Energy, Metrology, and Environment Research Group. Professor Oluseyi O. Ajayi has garnered various local and international accolades, including a State Honors Award during his National Youth Service course, multiple Chancellor's Outstanding Publication Awards, and recognition for exceptional PhD thesis. He received the Chancellor's Honors Research Award for Outstanding Research Output and was voted the Best Mechanical Engineering Department Lecturer in 2 academic sessions. Apart from his roles in various companies, he has received prestigious research grants, such as the British Academy's Global Challenges Research Fund and the Fulbright African Research Scholarship Program. He is affiliated with esteemed engineering organizations like the Council for the Regulation of Engineering in Nigeria, COREN, the Nigerian Society of Engineers, NSC, the Minerals, Metals, and Materials Society, TMS, and the International Association of Engineers, IANG. Professor Oluseyi Ajayi has also served as a keynote speaker at significant scientific and engineering events. He is married to Dr. Oluwatoyin Ajayi and blessed with lovely children. Please, would you rise up and put your hands together as I invite the inaugural lecturer to the podium.
Thank you. Please be seated. The Chancellor, sir, I want to first and foremost recognize my father, the royal father, the Oba Olupo of Olupono land. Kabiyesi, sir, Kadipe Lori Kibata Pelese, and my mother, the Olori Oyebamiji. You're welcome. The Chancellor, sir, please permit me to stand on the already established protocol. I'll be speaking to a topic on this inaugural lecture of today, tagged Sustainable Energy and Production Technology, Panacea for the Development We Want. Introduction and the overview of mechanical engineering. Because many of us, we do not know what mechanical engineering is all about. But I'm expecting that after today, everybody in the world will be a mechanical engineer. Because globally, that is the best profession that you can think of. The Chancellor, sir, my journey into academics is one of interest, born out of a passion for development of man. I have hoped to be a teacher as early as my days in the secondary school at Bachuman High School, Surulere, Lagos. I appreciated the commitment, zealousness, and sense of responsibility with which my high school teachers went about doing their thing, the passion and compassion they felt for us at ensuring we understood whatever they taught was vivid. Howbeit, the discipline method and communicated was unambiguous but formative. God bless my teachers. Somehow, throughout my time in elementary, middle, and high school, I found myself always close to my teachers. They usually invite me to their offices to assist in one assignment or the other, and would always look out for my feelings. I have felt blessed around many of my teachers. However, this closeness came with so much burden. Wonderful. The burden of being the class captain. I was class captain from my primary 3 to senior secondary 2. While others used the break periods to play football or engage in other sports, my teachers wanted me to help in recording tests or representing my classmates in certain assignments. This was not good in my head, but in other ways made me get into the heads of my teachers. And my interest was pricked into loving the profession. Moreover, while thinking to be a teacher, I equally wanted to be a professional, like a medical doctor, a scientist, or a pharmacist. Hence my choice of becoming a science student at the senior secondary school. One day, while preparing for my West African School Certificate Education, a teacher met me and requested to know what I would like to become. I happily replied him, I want to be a surgeon or a pharmacist. His response changed my course forever. He simply said, why would you like to be that? Although medicine and surgery, as he said, and pharmacy are not bad, but you are by far better in the mathematical courses. Your thinking is very analytical, and you will do well in engineering. He ended by saying there are very good courses in engineering. That short discussion of no more than 5 minutes changed my dreams forever. I'm a product of teachers. To that time, I had no idea about engineering because I was only thinking about being a medical doctor or a pharmacist. So, however, I had to think about what I would be for my first choice and second choice in what we call JAM, Joint Admission and Matriculations Board Examination. And I chose engineering, and precisely mechanical engineering. And so what is engineering, and why mechanical engineering? Permit me to answer this question by describing the engineering of creation and the idea of a mechanical engineer. The Holy Book described the earth at creation as a space that is formless, shapeless, void, and somewhat lacks appropriate structure. The fitting description of the earth was to call it a deformable body that can be transshaped, manipulated, or maneuvered to the desire of the Creator. It was, as it were, a simplified raw materials. The Almighty Creator went a step further to energize it to its particular shape, having well-defined structure and support systems. Astronauts and space scientists told us that the Earth revolves in its orbit around the sun, but we are not told what keeps it in orbit. If anyone knows, please, I'm willing to learn. The movement of the Earth around the sun has continued over how many years? Still, nobody told us the forces that keeps it in the axis of rotation. Could it be the attraction of the sun on the Earth? If it is so, why has the distance between the sun and Earth not been closer to zero than when the rotation began? Moreover, could it be the balance between the centripetal and centrifugal effects of rotation? If so, that is engineering. What suspends the Earth in the outer space? Even Job 26:7 says, God stretched out the northern sky and hung the Earth in empty space. Are there support structures holding the Earth from falling? A little probing on the engineering of creation also shows, according to scriptures, that man was created from the dust of the earth. What you see in Genesis 2:7. Without the breath of God, the human body is a pottery, and at best, a monument. Which means the breath of God energized man to life. Permit me, therefore, to state that the making of the earth, its positioning and forces of rotation, is a divine engineering at play. Also, it is to an extent acceptable to say that the human body is a divine engineering piece. The structure of the human body contains everything that supports its shape and activities, from the arrangement of the skeletons to the webbing of the nerves and tissues, and from the positioning of the heart and the circulation of blood to the store and discharge of waste. The body is indeed a complex engineering piece. So now, what is engineering? May I answer in simple terms by saying that engineering is what we see around us. The systems that surround us and that we use to do things is engineering. The building we live in and where we do things that we do are products of engineering. Sometimes the human body can also be classified as product of re-engineering. Bone fixation for fractured bones, heat pumps for cardiac patients, etc., products of engineering. Thus, engineering can really not be defined, but described or demonstrated. I know that in layman language, engineering is thought to be application of the knowledge gained from science. The idea of knowledge gained is in itself intangible and an abstraction of discovery. It is the outcome of that knowledge that is demonstrative, appreciable, and reality of what is learned that is engineering. Therefore, what is engineering without a product? Zero. It is the products that defines engineering. Engineering is the creation of products and systems to satisfy an intended purpose. Based on the aforementioned, engineering stands on two legs of product development and functionality. The functionality component takes its process from the energy that powers it. It is the derivative of what makes the product perform the intended purpose. This is the idea of a mechanical engineer. Thus, from the creation of the earth, what we call engineering is actually mechanical engineering, simply. Thence, mechanical engineering is understood to be one of the oldest and broadest engineering disciplines. In fact, it is referred to as the mother of all engineering. By way of definition, therefore, mechanical engineering is a field of engineering that involves the application of that knowledge and principles of basic science to actualize products that are functional, that are usable, and safe. Let me just go a little step further to consider some of the contributions of mechanical engineering to the society. Since the world began, mechanical engineering has taken the center stage on shaping our world. The first industrial revolution, tagged Industry 1.0, is mainly based on mechanical engineering. It involves the use of machines for production. It began the transition from handicraft to mechanization, and this led to mass production of goods and faster processes. This era witnessed the emergence of water and steam power machine. Subsequent revolutions, which we call Industry 2.0, Industry 3.0, Industry 4.0 that we are on now, and further to Industry 5.0, are just improvement of mechanical engineering systems. They are processes that mechanical engineering is all about. And therefore, it means that in all this race to improve our systems, in all these ways that people go abroad to want to do artificial intelligence, machine learning, and all of that, they are only tools to improve mechanical engineering activities. They are no substitute for mechanical engineering. All of the innovation and advancements are basically the contributions of mechanical engineering to national productivity through the application of various enhancing factors. In the automotive industry, the activities of a mechanical engineer begins from the design of the vehicle body to the construction, maintenance, and function of the engines. The engine cooling, occupant safety, and comfort are total functionality and aesthetics of a motor vehicle is just the activity of an engineer, of a mechanical engineer. Be that may, in today's world of social, economic, and environment practice, there seems to be a shift from the usual traditional way of doing things to the focus on the future. And it has changed from the development today and for this generation to the development today and for this generation with a concern for the development of future generation. This is the key concept of sustainability. One beautiful thing about Industry 4.0 is the introduction of sustainability to systems and practices. It is deliberately intended to safeguard future investments need, while development is focused on today's benefits. Hence, development is now viewed from the angles of social sustainability, economic sustainability, and environmental sustainability. This essential aspect of sustainability has become the acceptable standards as published in the United Nations report of 1987. As a result, engineering has gone beyond functional products development to embrace natural resource conservation and eco-friendliness. It has also beamed light on manufacturing processes with attention paid to efficient methods of production. The issue of resource conservation has also brought about the intentional improvement of our lean thinking. May I go ahead to look at sustainability as a concern of mechanical engineering? The Chancellor, sir. All of the aforementioned clearly demonstrate that mechanical engineering is at the center of Industry 4.0 and the sustainability agenda. The realization that our production processes must be based on eco-friendly raw material processing, while at the same time reduce carbon footprint, has brought about the aggressive push for changes in manufacturing and other mechanical engineering activities. The focus is shifting from brown technology to green. We are now encouraged to use green processes, green technology, and sustainable energy to drive manufacturing and reduce the emission of environment malignant substances, like the VC mentioned. Now, it therefore means that the way we do things has shifted from traditional bringing this and that together that leads to greenhouse gas emission to lean thinking, to thinking environmental sustainability, and mechanical engineering is at the heart of all of that. May I go ahead right now to look at Nigeria and sustainable development? Where are we and where are we going? And let's look at the influence of sustainable energy resources on Nigeria. The Chancellor, sir, please permit me to state that the manufacturing sector and other economic sectors will not do well if there's no sustainable power supply in terms of quality and quantity. It's a known fact that the impact of access to electricity on the economy cannot be overemphasized. There exists a causal relationship between energy access, industrial growth, and the growth of industries. Many researchers have actually established this and corroborated this. Ajayi et al., Akiyemi et al., Bacharayo et al., all of those in 2020, 2018, and 2017 had shown truly that there's a causal relationship between energy access, population growth, and even economic development, with renewable energy being the standard. Nations with high energy access have experienced rapid industrialization, low unemployment, and well-developed information and communication industries. Modern healthcare services, literacy program, and other sustainable development goals will also do well when there is adequate amount of energy. Ladies and gentlemen, while a strong, well-developed manufacturing sector depends largely on availability of raw materials and quality access to modern energy supply, Nigeria's manufacturing sector suffers greatly from the lack of access to grid electricity supply. This has, over the years, led to the major challenges bedeviling the nation's industry. So if all of these are happening to Nigeria, the question is there any hope for a sustainable development in Nigeria? Well, the federal government has, over the years, shown the willingness to alleviate the nation's energy situation with the adoption of the Renewable Energy Master Plan. There's the Renewable Energy Master Plan of 2005, the Energy Vision of 2020, but be it as it may, all of these master plans set out generation targets for renewables and all of that. But up until I speak to you, no targets fixed by the federal government has ever been met, which means, as a result, Nigeria set generation targeting, but have not been able to meet any one of these. Let's look at the development we want, because the topic says sustainable energy production, and sustainable energy and production technology, panacea for the development we want. Many have asked me, why development we want? Why not development we need? I understand. Because economics told us that human wants are insatiable. You cannot meet them. But today's market dynamics has shifted from the traditional production-based economy to embrace sophistication. The modernization has ensured that the concentration shifted from the classical manufacturing-dependent market to the era of IT, leveraging development on smart and transformative technologies. Most important is the fact that the Industrial Revolution is presently learning on the concept of cyber-physical transformation of the manufacturing processes that involves data-driven artificial intelligence to create smart manufacturing processes. This revolution incorporates the Industrial Internet of Things, big data analytics, machine learning, and artificial intelligence. However, despite this modernization and level of sophistication, it has been discovered that the development of a national economy is still largely skewed towards the baseline production sector. How can you think or talk of development without a viable manufacturing sector? Hence, the modernization only improves the market structure and promotes development. It is also worthwhile to know that the innovation created by the sophistication enhances production and drives towards Industry 5.0. Consequently, all of these add up to give us development and further development to deliver much more than what is required. Hence, while energy availability and access and production technology delivers national development, the new trend of innovation and automated ways of doing things further enhances development and gives more than we need. It therefore means if Nigeria is intending to have more than development that we need, what do we need to do? Increase energy access and improve or enhance our production capacity. Once we are able to do that, with the new wave of IT, new wave of smart technologies, new wave of running to machine learning and data analytics, what we have is development, further development, and further development. It delivers to Nigeria that development that is beyond our need, the development that we want. In all of this, what's my specialization? Because I want to tell you, in choosing mechanical engineering, I narrowed it down to what fields of mechanical engineering. There are 32 divisions of mechanical engineering, and no man can read it all. You can only maybe specialize in one or at most two. In fact, I looked at man, the human structure, and mechanical engineering is everything about man. Please let me turn to your neighbor and look at your neighbor straight in the eye. Can you help me do that? And just shake that neighbor. You're a machine. Oh, you are not doing it. Please do it. Shake that neighbor very well and tell them you are a machine. From the chewing of the food to the swallow of the food, the peristalsis that takes the food from the mouth into the stomach is mechanical in operation. The digestion of the body is mechanical. Everything, even the way the small intestine operates until you pass out your feces is mechanical. The movement, the shaking of... There is no way you move without your hair shaking. Mechanical engineering. Why do doctors talk about eardrum? There is a drum, a percussive instrument. The beating of that drum makes you hear. Why are we talking about voice box if it is not mechanical engineering? If that voice does not have a box, there is a trouble. All of these are mechanical engineering. And today's innovation is even all about mechanical engineering. You now find a plane having a brain box, wanting it to look like man. That brain box is just talking about man. Modern vehicles today have what you call what? Brain box. Why are they looking for brain? Because everything is about mechanical engineering. Thank you. My specialization, therefore, in all of these In settling for my choice of where to specialize, I realized that there are various ways to analyze phenomena. And that is one key thing I'd like us to know. We could see anything or any idea from what is happening, why it is happening, and from the angle of how it is happening. The concept of what is the philosophy of what did you see, taking its sides from the observable inferences. Just like a malaria patient develops fever, flu-like illness, and shaking shoes. We call it malaria. But do you know that that is also COVID symptoms? So merely looking at symptoms, observable inferences, does not actually tell you what is going on. You need to reach to the body and take samples. And that means you are looking at why is what I'm seeing happening. And the concept of why, on the other hand, is a philosophy of what is the causative agent. This leads to approaching the body system to find out what could be responsible. For the case of the patient, the doctor orders for blood sample test or other tests. In mechanical engineering, we go for the material mechanics, which invariably is solid mechanics under the production technology. So while I was thinking, from day one, I was intentional. I want to be an energy expert. But how do I want to be an energy expert? Do I want to approach it from solid mechanics or from fluid mechanics? But I realized that my colleagues, no insult to you, that when it comes to fluid mechanics or what we call thermofluid, you are only treating the symptoms. You are only looking at the observable inferences. You are looking at temperature, thermodynamics, or heat transfer. Those are symptoms. And I don't want to go on symptoms. I want to be able to approach the solid body, to be able to understand the material mechanics, governing the interactions, governing the observable inference. So in choosing my choice, I settled for production technology to answer energy. So, in all of these subfields of mechanical engineering, I chose to focus on two divisions, which are energy systems and production or manufacturing technology. To develop the interest in production technology, after working for a while post-bachelor's degree, I went to University of Nigeria, Nsukka, to become a big lion, to pick up a master's degree of mechanical engineering with specialization in production technology. The period of training exposed to me the interrelationship between design, material selection, and manufacturing. It gave me a clear expose on the interplay that exists between the product design, planning and implementation, development, maintenance, and process control, leading to the manufacture of a product. The outlook of a production engineer, therefore, is the valorization of raw materials. Production engineering shoots from design and manufacturing to operation and supply chain management. It blends science and engineering together to make quality products. In developing interest in energy system research, I realized that production technology enhancement thrives on sustainable modern energy resources. However, energy system study as a field is in itself a whole of mechanical engineering. If there are 32 divisions of mechanical engineering, I will tell you the truth. There are also several divisions of energy systems research. Let's now look at theoretical, methodological, and conceptual reviews. Why are we here today? Let's establish the production capacity of Nigeria and everything about this lecture. Going by the aforementioned, the Chancellor, sir, no nation can develop beyond its capacity for production. That is the truth. Even if everybody in this hall becomes an IT specialist, Nigeria will not develop. Without production, there is no development. If every one of us run after machine learning and we run after computer science, without production, there is no development. The production technology is the in thing, and then sustainable energy that powers the production. The transition of a country from underdeveloped to developing and further to become a developed nation is governed by manufacturing and technology. According to statistics, the United States of America market size for mechanical engineering in 2020 is placed at $421 billion US in market size for mechanical engineering. And this is about and it's a projected 7% projection rate from year 2020 to 2030. These statistics, however, has been doubled by China way back 2015. And several other countries had their own market share, 14.4%, 35.8%, but I like to focus on Nigeria. According to the National Bureau of Statistics, the evaluation of the contributions of the manufacturing sector to gross domestic product of Nigeria for the last 4 years depicts that the sector contributed, listen please, 6.47 trillion naira in 2019, 6.29 trillion naira in 2020, and 6.50 trillion naira in 2021. That is our manufacturing sector. These values amounted to an average cumulative contributions of 9% to the GDP between the year 2019 and 2021. Let us compare it with agriculture. Within this period, agriculture alone contributed more than 25%. Around 25%. And let's break it down. In 2019, 17.96 trillion is the contribution of agriculture. In 2020, 18.35 billion. And in 2021, 18.74 billion. Compare that to manufacturing. While manufacturing is doing single digits, agriculture is doing double digits. In addition, Nigeria's manufacturing sector nominal growth, GDP growth, in the second quarter of 2022 is put at 5.21% year-on-year, with a contribution to nominal GDP of 12.97%. The National Bureau of Statistics has continued to show a decline in the contribution of manufacturing sector to the GDP. These statistics suggest that the production of higher value goods is still a far cry from Nigeria, and that export earnings from manufacturing is low. However, with the availability of raw materials, the statistics are loose to the fact that the export of raw materials dominates the nation's export earnings. Suffice then to say that no nation can grow by exporting its raw materials. The development of a nation is hinged on value addition to its raw materials. Let's look at the practical application of all of these statistics to the society. Why are we where we are as a nation? Going by the economic indices, Nigeria is not doing well in terms of export earnings from high-value goods, which are products of viable manufacturing industry. The majority of our foreign exchange earnings are majorly from export of raw materials. These raw materials include crude oil, agro-allied products, and solid minerals. And according to the Nigeria Industrial Revolution Plan of 2014, no nation develops by exporting raw materials. And the more a country specializes in the production of raw materials only, the poorer it becomes. Could that be the reason why Nigeria is poor? Therefore, the state of Nigeria's development stems from the performance of our industry, and the contribution of the production of manufacturing industry to the growth and development of a nation cannot be overemphasized. The Ajaokuta Steel Company Limited was created from the efforts of the Nigeria Steel Development Authority and established in 1979 to advance the development of the Nigerian steel industry. Just imagine a functional Ajaokuta steel industry. There will be sheet metals for vehicle parts. There will be roofing sheets, materials for roofing sheets. We don't need to import anything. With all of this, may I focus on my accomplishment? Since I became a lecturer, since I chose to specialize under two broad divisions of mechanical engineering, permit me to lay out my contributions, just a few of them, under these two headings. First, I start with production technology, then later on manufacturing, on energy systems. My contribution within the production or manufacturing engineering field of mechanical engineering are in the thematic areas of stress, fatigue, and failure analysis, environment-induced failure or corrosion of metals for design technology, and surface engineering. Based on this, my first contribution was to the steel industry. And what did I do? The study was on the modeling and simulation of crack initiation and growth in particular composite with high alloy steel as case study. The study was idealized from the concept of the Griffith's law and its subsequent modification to investigate the different factors that affect crack initiation. The study used the stress intensity factor together with the rate of crack growth per cycle of loading to model the rate of crack initiation and growth in high alloy steel, particularly the magnesic steel. Magnesic steel is a metal that you can use to create valves or machines, any kind of machine. It's a very, very good material. However, it is not a material that thrives on strength, but on fatigue. And so if what you are interested in is to avoid failure, magnesic steel is good. Now, one major issue of resolution in using magnesic steel, and based on the theory, is that in any time there is a crack initiated, no matter how small, the energy for that crack to grow becomes reduced. Because a crack initiated reduces, automatically means a reduction in the energy capacity to withstand or resist pressure. And then the rate of crack begins to grow. It therefore grows to a point in which there's a sigmoid curve. And beyond that point, from the point of sigmoid, and above that point, there is no way you can analyze the metal for the future. Therefore, the study mathematically modulated the sigmoid function to capture the material response beyond the point of sigmoid. Hence, the time-tested response of the material from installation to failure can be determined if the loading variables are known. For that particular research, we therefore, using mathematical modeling, were able to change the curve and make it a straight line. And therefore, we could predict, it's a lot of mathematics, we could predict from the day you install that machine, knowing the loading variables, we can tell when that machine will fail. And therefore, it helps maintenance, it helps production processes. May I continue? That research was done in air environment, and we were able to see the signature of that material. And now it will behave from the day of installation to the point of failure. And therefore, I understood that if this is done in air environment, what about if it is brought under the ground? If that material is used to construct pipelines, and you pass crude oil or gas through it, what will happen? Under the ground, it behaves like a sulfuric acid. And therefore, we began to look at the study of corrosion. We therefore discover that when something comes into a volume or into a medium, it changes its microstructure. The behavior changes. And the property begins to attenuate. And it begins to look as if it is not the same property or the same material. So what do? How do we arrest corrosion? Since corrosion cannot be arrested totally, but can be slowed, we therefore decided to go into the study of corrosion by looking at the Gibbs free energy and how to attenuate or alter the performance of that material from the Gibbs free energy. And that brought us to looking at ways by using natural products, organic products like Siam weed and all of those plants to be able to aid the reduction or slow down rates of corrosion. There are so many things I like to say there, but let's just stop. This corrosion had been worked on severally, but we chose a methodology different from every other thing. Rather than doing gasometric method, gravimetric method, which is the weight-based method, we chose to use the gasometric method, which is the rate of hydrogen evolution, predicting the rate of corrosion. And we know that whatever can predict the rate of corrosion, we also predict the rate at which that metal is degrading in that environment. And whatever slows that rate of hydrogen evolution, we also slow down the rate of corrosion. And what do? We had to use organic materials, like your Siam weed, like your bitter leaf. When you cut the leaves off, you throw the stem away, like coconut, the back of coconut. All of those waste, melon, all of those waste, we therefore worked on it and began to use it to reduce the rate of corrosion. May I continue by saying that when all of that was done, we now began to predict the rate of corrosion and what happens in the material. There is an equation I would have loved to show if it is there. That is equation 7. Up until our research, there is a general equation, and that equation is equation 5, or you can start it from equation 2. That was the governing equation. We began to look at ways to alternate that equation and predict the rate of corrosion when an inhibitor is in place. And we came to equation 7. And in equation 7, even though it looks like equation 5, there's a negative sign. That negative sign came after rigorous research to be able to see how can we predict the rate at which a metal with an inhibitor will perform. And then that negative sign became novel because it showed us that even though all the other equations exist, this negative sign is now for the inhibitor performance, inhibitor work, showing to us that unlike previous studies, this negative now describes the inhibitor property. So when you now have this equation, you can pick a metal once you know the value of K, once you know the value of C, the rate of corrosion, without experimentation. And then after that, we also moved on to look at, okay, having known all this and using plants that are normally, like tobacco, for instance, plants that normally people don't eat, plants that maybe after you have squeezed your juice, the peels, the bark, these are waste, agricultural waste. How can we make use of them? We therefore went to pick orange, and particularly the peels. And we were able to, at the nanoscale, use it to do what? To coat metals. were able to enhance the coating of metals, and after much experimentation, we discovered that when orange is added as additive, the surface finish is better. The metal looks better, looks brighter, and the performance is better. On product development, the Chancellor, sir, we have made some significant contributions. For instance, we carried out a study and developed a rotary vane pump for crude oil waste extraction. We noted that in the oil and gas industry, the evacuation of crude oil waste involves the use of pumps and trucks, which by virtue of their design do not have a good cost-to-lifespan ratio. While the pumps extract the contaminated fluid oil waste by suction pressure, direct contact between the corrosive waste and pump or tank parts have detrimental effect on the material properties of the pump, leading to frequent failure, and this needs parts replacement. The cost of replacement runs into millions per annum. As we were told, that every 3 months, they would have to change that pump. And the pump at that time, 2011, cost 3 million naira. Based on this, the study developed a fluid extraction vacuum system that provides dual purpose of pumping and suction effect without the need for a contact or interaction between the fluid and pump parts. An intuitive tubing system that can reverse the flow process of the vacuum pump to impress both negative and positive pressure force was introduced, and the developed system was tested and approved. But one big thing about this is that because the student that worked with me on this project owns a fabrication company and gets contract from NNPC, he had to come with his son, sent his son to say, please, tell your lecturer, it's my money they used. And it runs into a lot of money. And so they begged, please do not own this. Let us be the owner. And today, NNPC bought that technology from them, and it's being used. In another research, we discovered the spur gear system of a filler machine, and this is an industrial project, of a filler machine in a beverage company undergoes rampant failure that necessitates several operational or machine downtimes. The situation necessitated our investigation into the possible causes and possible solutions to the problem. For this purpose, on-site investigation of a filler machine was carried out for 20 days of 12 hours of operation per day. The findings indicate that rampant failure of the gear tooth occurred such that there was a tooth fracture every 3 to 4 hours, until criticality, when a tooth fracture occurs every 2 hours. To resolve this, the approach was divided into 2. The first was to mathematically model the idealized spur gear system in operation, and by it investigate the interplay of forces that led to the failure. The second was based on the outcome of the first, and we carried out an experimental material development in order to create new materials that can withstand the operational and environmental pressure. When we saw that the modeling was good, and it predicted that the situation of failure is caused by material, wrong material usage, number 1. 2, not matching the material appropriately with the operational principles. We therefore went ahead to create a new material that can be used to cut that gear and made it operational. Because we discovered that in the environment that gear operates, there are alcohol, because it's from an alcoholic company. There are drippings of alcohols on that, of alcohol content on that metal, and that chemical attack aids further corrosion and increase the rate of failure. We therefore used some agric waste, palm kernel, sawdust, wood charcoal, was therefore used with a metal to strengthen the surface of the metal, to improve the energy of the surface of the metal. And after we'd done that, a lot of rigorous activity went on. We worked between the temperature of 700 and 900 degrees centigrade to be able to create a new metal totally that can operate in that aggressive environment without failure. And we took that gear back to the industry. It was inserted for 6 months before. You saw what I said. After, at point of criticality, 2 hours, you find a tooth failure. However, after 6 months of operation, that gear keeps on rolling. It keeps on working. It means we solve that industrial problem. My contribution within the field of energy system, I went for a PhD in this area because I needed to learn what it is all about. And my first contribution was in wind energy. And several efforts had been made in the past to characterize or look at the characteristics of our wind regime from site to site, state to state, but not covering the whole nation. However, the United Nations Environment Program stated that the whole of the West African region has enormous potential for wind and solar power, capable enough to power the whole of Africa. But the problem there is there is no measurement. No adequate measurement that will convince investor or attract investor to bring in their money to invest in our wind energy industry. And therefore, we carried out that study by looking at the whole of the meteorological stations in Nigeria, 40 stations, and took 21 years wind speed data and analyzed. And therefore, we are able to develop the map of Nigeria, the comprehensive map of Nigeria, wind map of Nigeria, both for dry season, both for wind season, and all year. Because the signature of our wind power system, of our wind regime, is different from weather to weather. And then we are able to analyze that. And then I work with also a doctoral student, because apart from the onshore sites, from state to state, what about our offshore locations? And then I work with a doctoral student who now went ahead to look into the wind classification of our offshore sites. And we're able to locate 60 sites up to the 50 nautical miles into the ocean where Nigeria can power our system, power our economy by wind, through wind. And we're able to discover that terawatt-hour of wind power can be generated from our offshore facilities. May I go ahead, the Chancellor, sir? My research team and I have deliberately used the outcome of our researches to show that there is value in waste. We have used several wastes. On energy alone, from wind, we went to solar. From solar, we also worked on our air conditioning system and our refrigerator system. Do you know that when you eat watermelon, that peel you throw away, we have used it to enhance the cooling of air conditioning system. We have used it to enhance the cooling of our refrigerator system. Do you know that banana that you eat and you throw away the peel is a very good system for our ACs? It's a very good system at nanoscale for our refrigerators. We have done all this to show that there is value in waste. Tons of agricultural waste from palm kernel, coconut shell, eggshell, and all of that have been used in the past. Some of my achievements within Covenant University. I joined CU with no published article. Today, I have over 200 publications. My thesis, together with the thesis of Dr. Olasende of Biological Sciences at the year we finished, 2010-2011 session, was picked as the two best theses in CU. To the glory of God, I have won several awards, publication awards, as has been said, international awards, and recognitions. The Chancellor, sir, I have supervised several undergraduate research projects. I am proud to have access to excellent students of particular mention at three of them: Onome, Teddy Okolo, and Daniel Ukasoya. Each of these students, their own projects, had gone ahead to push them to great heights. While Teddy Okolo was working using watermelon to enhance the cooling of AC, he was interviewed by a professor from the University of Saskatchewan or something like that in Canada. And when he talked about his work, he designed another project similar to that for him and gave him fully funded research to come to Canada. Also, Onome, through his project, became the second best in Nigeria by the Codet Award for Outstanding Project the year he graduated. And then Daniel, his own project, won an international award and earned him Chevening Scholarship. Today, Daniel Ukasoya has gone far ahead and has finished a postgraduate study in Cambridge University. They have all continued to look at it. Based on this, I have plans for the future. This is an inaugural. It's just as if I'm starting again. Whatever I've achieved, I've thrown it away. I'm starting afresh. And based on that, I have plans for the future. We have indeed done a few things right, and by the grace of God, earned this right for this inaugural. However, despite some of our research outcomes, there are much more to be achieved. My future research plans are focused on converting some of the results of our research investigation to market-ready products. For instance, in our study on corrosion protection, we have employed the methodology of hydrogen gas evolution to predict the rate of corrosion. However, there is yet to be a suitable time-tested commercial equipment that instantaneously correlates the volume of hydrogen gas evolution to the magnitude of material erosion. The objective will require a collaborative effort for the development of a hardware that utilizes the embedded systems. We are actually working on this. Ladies and gentlemen, we have determined through various investigations that doping the compressor oil with metallic and bio-based nanoparticles improve the heat and mass transfer of both vapor compression refrigerators and air conditioning system. The system consumes less energy and are made more efficient. How do you think it, if you go to the market and you buy compressor oil, and say that compressor oil is made with watermelon peel as nanoparticle, and that is what is driving your compressor? It will be beautiful. Further to this, we are continuing our collaboration with international partners to continue our efforts in developing more efficient wind turbine systems with improved startup capacity at low wind speed. Also, it has been noted that energy poverty and energy crisis are some of the key drivers of human migration. Improvement in National Human Development Index, as well as the achievement of the Sustainable Development Goals, are hinged on access to modern energy resources. This we know. So what should Nigeria do? The recent trend of our energy poverty can be tackled if Nigeria can improve our policy, our energy policy, and begin to look at, number one, our laws. That is what we call pioneer status. And the pioneer status does not recognize renewable energy. It only recognizes solar. We need to extend it to cover for it. We need to give some incentives, economic incentive, to wind power investors so that we can attract them. To those in my constituency, the academia, we need to do more in research and development. We must seek for global solutions to our local research needs. We must keep pushing the frontiers of knowledge, making contribution to our national development. Let's reverse the syndrome of what is going on. This Japa, let's just turn it to Kapada. Because if we begin to improve the way we do our things, Japa will become Kapada. They will return, they will return, they will return, they will return. The only reason why they go is because where they go recognizes human capacities, recognizes human contributions. So if we begin to recognize our own contribution, Japa will become Kapada. Finally, please record that I had wanted to be a medical doctor or a pharmacist. I am a machine doctor. That I've used plant resources to alter the phytochemical and thermal properties of metals. Acknowledgement. First and foremost, my deep and sincere appreciation goes to God Almighty, who has made this day a possibility. Praise the Lord. I want to thank the Chancellor for listening to God, the Chairman of the Board of Regents for listening to God and setting up this citadel of learning. I am a proud product from this school. I want to thank the Vice Chancellor and the management of Covenant University for running the race, for lighting the torch, and showing us how to lead. I also equally want to thank my teachers from my nursery school to my PhD. Late Professor Richard O. Fagbenle, my PhD supervisor, Professor Katende, my co-supervisor, late Professor Antonio Dukwe, my master supervisor, Professor Koya, and all other persons I could not mention. But I know that many of us would like to get the complete text. You will see is outside. Closing remark, the Chancellor, sir. World-class universities are not just globally recognized standards of quality education. They are places of robust scientific and intellectual development, created by the rich mix of outstanding learning environment, creative manpower resources, talented students, purposeful and contagious vision, and the undying passion for excellence. Covenant University fits this description. When I joined CU in 2005, my colleagues at the Federal University did not believe I acted well. They queried my decision-making and thought that I acted in error. One said to me, "Why would you join jettison a known university with a big name and globally recognized for an unknown?" I replied then, saying, "The Federal University's name and recognition was acquired by the performance of its lecturer, staff, students, and general achievement over the years. I am going to see you to contribute to the development of our name and recognition." I think I am doing that. Then I was driven by the idea of helping a Christian university attain its envisioned goal. I was fascinated by the inner passion that Christians should help Christian organizations grow. Little did I know that I came into a jet engine with the capacity to transform. Indeed, CU is a departure philosophy. As I work to make, thank you very much. As I work to make my contribution, I get imbued by greater work ethics, increased drive for excellence, insatiable intellectual curiosity, and cravings to add not to knowledge. Let me therefore acknowledge that where I am today and wherever I want to go, it's by the glory of God. Finally, permit me, therefore, to close by using the same phrase that Professor Charles Ogbologo used in his inaugural lecture in 2013 by saying, "This and many more are what I have done, but this is my inaugural." Thank you for listening.
I'm sure we can make it louder for the inaugural lecturer of today. Thank you very much. You may please be seated. I am very sure that our minds have been challenged by that presentation, and our imaginations have been stirred. Thank you very much for that presentation. Please, let's put our hands together again. I am very sure that there will be a lot of appreciations coming in for how this event has come to be today. But of course, one of the persons who will appreciate over and over again is the amiable wife of the presenter of today. Please put your hands together for Dr. Oluwatoyin Oajayi. Thank you very much for your part of this success today. Ladies and gentlemen, I'd like to bring up the Vice Chancellor to please perform the next function. The Vice Chancellor, sir.
Thank you so much, the Chancellor, sir. There is no doubt that we have been treated to a very, very rich meal today. How many of you are excited to witness that inaugural lecture presentation? Thank you so much, Professor Oluseyi. Now, we're going to be receiving the Chancellor of Covenant University, Dr. David O. Oyedepo, who will be coming to make his own remark. But he's not here physically, but he has sent a representative. Please permit me, therefore, to ask that we rise as I warmly invite Pastor Niyi Beecroft, standing in for the Chancellor of Covenant University, to make his remark. Put your hands together for him as he comes forward.
Your Royal Highness, Oba Rafiu Oyekanmi Mushobalaje Ilefumiloye. I believe I got it right, sir. Your Highness. And the Olori, the Olupo of Olupono, Iwo, Osun State, and our Royal Highness. You're most welcome. I would also like to recognize the Deputy Vice Chancellor, Bells University of Technology, Professor Pearl Okwobo. You're most welcome, ma'am. Also, the former Deputy Vice Chancellor, Federal University of Agriculture, Abeokuta, Professor Muftau Adekojo Wahid. You're most welcome, sir. I would also like to recognize all former chapters chairmen Nigerian Society of Engineers. I believe they are here, seated in various positions. You're most welcome. I also understand the former national and all former chapters chairmen of the Nigerian Institution of Mechanical Engineers are here or represented. Again, you are most welcome. Mr. Vice Chancellor, sir. Okay, please be seated. Thank you very much. Thank you very much. You can see that they say that new honors come upon him as our old new garments stick not to their mold, but to the aid of use, as Shakespeare. So please forgive me. I'm just representing the Chancellor. I want also to appreciate the Chancellor, who truly is a maker of men. My background is academics, my training, but I've been long retired. I left Ahmadu Bello University in 1993 as Associate Professor of Chemical Engineering. And January 1993, and I've been serving in various positions. At the moment, I'm a farmer here in Ota. So, and I now find myself also still an academic in every respect. You must look to the Chancellor for that. He's able to identify people and put them in a position that best enhances their ability. That's been 30 years ago since I left ABU. I want to thank, I think I will leave that till later. I first want to start by commending the inaugural lecturer. And he spoke very seriously to the course of mechanical engineers. And it's quite common for all of us. If you ask the mathematician to get up, he will tell you God is a mathematician. If you ask the geographer to get up, he will tell you very succinctly that God is a geographer. And even, of course, well, the women haven't yet told us that he is, but God himself describes himself as El Shaddai. El Shaddai means the full-breasted one. So you can also see the women. But whereas each one of us tries to say that, it is us, well, it is significant that God encompasses all of those attributes. And that's what makes him God. And I think what he's doing is pointing to the fact that what we need to recognize is the contributions we can all make. Whatever it is that we have is most welcome. And what we must learn to do is to unite our efforts to make things work, to produce things. That is the note on which I will end my few remarks, but I will leave that till later. I want to again commend the inaugural lecturer for the very beautiful presentation. And I want to thank God that in a very brief few years of existence, just barely 21 years, and we've had 30 inaugural lectures. It's amazing. The more likely thing is that people have existed for 10 years and they are still struggling to have the first inaugural lecture. Keep postponing, but thank God. I want to encourage my colleagues to please keep up the spirit. Let's keep doing that. Let's keep producing. That's the way to go. And this time at the back, we have a list of the illustrious previous inaugural lecturers. They are people worthy of celebration. I want to thank all of faculty. I want to thank the management in particular, and with them, all previous management for sustaining the spirit and keeping the flag flying. Please go ahead with that. I want to congratulate the current crop of lecturers who are still holding on the flag. These are trying times, as we all know very well. The inaugural lecturer spoke about the Japa spirit, and he was recommending that we should kapada. That's right. Thank you very much. Well, we should all call back. And that is something that I personally feel. It's even more serious than just kapada. I'm a father of 6 children and grandfather of 13. And now listen. Of those 13, I think just 2 carry Nigerian passports. And I find that replicated all across. Most of my colleagues, the children are gone. They're gone. Of my 6 children, 4 are permanently based abroad. The 2 in Nigeria here, One is virtually an international citizen. The other one is a military man, so he really can't go out. But all their children, like I said, of 13, only 2 carry Nigerian passports, and that's because they're still babies. I'm sure that before long, they're going to find their way there. And so we even have a nasty situation in our hands that the developing demography, particularly in the Southwest, is such that we're going to have difficulty even laying claim on our place here. So it's not just a matter of, even now, if you provide solutions, how are you going to persuade somebody here into earning $200,000 per annum to come back here and earn 2 million naira? How are you going to, what will be your argument? Plus all the challenges. So we have a big job on our hands. One of the things that will help, of course, is if we continue to produce solutions, and that's why I thank God for the Inaugural Lecture, a whole list of solutions of things that have been done. And I want to encourage that that attitude should continue. However, success in life is not winning in somebody else's battle. Success in life is winning in your own battle. You might, prefer to be in America, where the research system is all well set, and the products are utilized quite easily. But that's not your battle. And winning in that battle is of no consequence. The battle you must win in is the battle here in Nigeria. This is where we must win. This is where systems must run. And I want to say that that is not, peculiar. Paul told Timothy in 1 Timothy chapter 6, I believe. Put that on the screen, studio. 1 Timothy chapter 6. Fight the good fight of faith. Lay hold on eternal life, whereunto thou art also called, and hast professed a good profession before many witnesses. The battle you are called to fight is the battle here in Nigeria. This is where you are called to win. And fantastic papers in good journals might be great. What we need to do is to collaborate together to begin to find solutions to the problems here. Not just writing papers about them, but, as you said, market-ready products. Products ready for the Nigerian market. I'm going to end this on that note, so please wait for it. I want to say that this is not the first time. This has been the trend in all the ages. The challenges that come to us are not always the ones we would like. Look at the case of Daniel. Daniel's own challenge was even self-imposed. He was selected against studio, Daniel chapter 1, verses 3 to 5, 8. I don't know how you're going to choose it. I will just make the relevant verses that are critical. He said, was chosen among the best of the children. The king spake unto Ashpenaz, the master of the eunuchs, he should bring certain of the children of Israel, and of the king's seed, and of the princes. Continue, please. Studio. And the king appointed them a daily provision of the king's meat, and of the wine which he drank, so nourishing them 3 years, that at the end thereof they might stand before the king. But Daniel said, I'm not taking it. And I'm sure when you study the Bible ordinarily, you will not easily see this issue of the fact that the king's meat will defile. Somehow God made it known to him. And God made it clear, if you want to serve me, you cannot defile yourself with this meat. It was something which he realized personally. And that's the battle he had to fight. And the man fought that battle. He begged, don't give me that meat with all of the pleasures, and I will stand the consequence. And he won that battle. So it is that battle that he was called to fight. When he came to the time of his manifestation, Daniel chapter 2 again, studio, verses 1 to 9, it was Nebuchadnezzar now who dreamt. And he dreamt the dream, and it was an unusual thing. So he called the people together. In the second year of his reign, he dreamt. His spirit was troubled. His sleep broke from him. Continue, please. He commanded to call in all the magicians. Continue, next verse. And after he called them together, he said, come and tell me the dream. I've dreamed the dream. My spirit was troubled to know it. Continue, please. Continue, studio. Yes. Tell me. So they said, look, tell us the dream. We will tell you the interpretation. I mean, the man said, no, the dream has gone away from me. You must tell me the dream and the interpretation. If it's not that way, you can just come together and begin to analyze A and B and put probabilities together. I don't want that. I want you to show that you have an element of the divine. You can see through what I'm talking about. So if you don't demonstrate to me that you have a contact, if you have a contact with the divine, you will know the dream, because the dream came from God. I want someone who is in touch with God and understand the dream that he gave me and then can interpret it. Then I know you are not doing abracadabra or doing permutations with me. And if you don't do it, I will kill you. That was the challenge. No other one. You can be brilliant. And actually they came together and said, look, nobody has ever asked anybody of this type of question. Tell us the dream, we will interpret it. Don't mess around with me. If you do it, I will kill you. Then Daniel went in. And he went and asked of God. And God showed him the dream and showed him the interpretation. That is the battle. That is the victory. That is the success he was required to have. So please don't tell me about the challenges in Nigeria. They're there. We know them. Don't tell me about the corruption. Yes. And that's what you must walk through and win. And win. And win. And all our challenges are crying for solutions. That's what they are. At the end of the day, what we need are solutions. Whether it's the political system, whether it's the economic system, and it doesn't matter whether it is mechanical engineering or chemical engineering or whatever, no engineering, our systems are crying for solutions. And I want to say, let's begin to emphasize collaborative efforts. Very quickly, I spoke about Daniel. I won't talk about it. I think I will just skip. I think that's sufficient. There are many other examples. Look at Ukraine, for example. Ukraine is not fighting the battle you normally want to fight. Every analysis I have seen put Russia so much ahead of Ukraine. They should not be on the same battle together. But that's the challenge which they had. What's even worse, Russia will say, I can strike at your population. I can strike at your civilian enterprise. I can strike at your... If you dare come around my own, you are in trouble. And even their own allies told them, don't strike inside Russia. How can you fight a battle like that? A man came into my territory, took my territory and took it over, and on top of that, he's still striking beyond it. And you say, I can only fight for that territory, I can't strike it. But gradually, Ukraine has changed the narrative everywhere around the world. Not only is it winning on the ground, some of me, where did they start off? February 2022. Where are they now? It's been a net gain for Ukraine from that position. And Ukraine will, I believe, they're still winning in every respect. But the greatest thing is the fact that they have captured the narrative all over the world. Their position is being heard, and they are fighting and winning. They have no navy, yet they are striking the Russian navy. They brought down their lead ship. A nation without a navy brought out the captain, where the command and control of the other enemy is based. That is the battle we are called to fight. That is where success is to be rated. So it's no point to begin to say, oh, if I were in the American Navy, if I was in the American Army, they have AWACS, they have, what's it called? What's this aircraft called? F-35, that stealth aircraft. They have all that. We know what to do. Meanwhile, they are pursuing the argument to get F-16s, which what they can get. And they are moving forward. They are inventing their own. That is the battle you are called to fight. It's in Nigeria you are called to win, and you will win. I'm going to end on one thing. We say get market-ready products. And also, a very important part of the inaugural lecture is waste utilization. Waste utilization. Let me share with you one of the things, coming to live in Canaan land, live in Ota, was with a great struggle with my family. My children said, how can you live in Ikoyi and come and live in Ota? I've sold properties in Lekki and come here. Daddy, what is wrong with you? This is the place with the highest real estate growth in the world. So how can you live and be pursuing Ota? But I came here under strong conviction. And one of the things I will share with you, I have very, very strong conviction that, Solomon, in his days, he made gold out of the dust in Jerusalem. And that's basically what God is doing before our very eyes. I'm glad the Chancellor is not here today, so it's not something that is being said to impress him. Gold is being made out of dust. And I thank God for the research that's going on waste. But I want to share one experience very quickly. I'm going to end on that. When I was in academics, there were a few of us, and we started a department in Zaria. chemical engineering department. Each one of us had our views about our research area. And just as the inaugural lecturer said here, I'm a mechanical engineer, I'm a chemical, I'm a biologist. Everyone wanted to pursue his own research line. But there was one, I'll put it, crazy boy, who said, no, all of you should cancel your research areas. Let's combine together. At that time, it was on ceramics. And we all thought this is a mad boy. How can you be saying that? He said, look, all our energies are dissipative. Each one of us cannot pursue any of these lines to any suitable degree. The solution for us in this small department is to unite together, face one area. And you are looking at various aspects of it, but in a short time, we achieve good success. I want to put that across to us much more. Let's learn to collaborate, form work groups, interdisciplinary, aimed at achieving, producing market-ready products. And one of the areas we can start is with waste utilization. And I want to give a particular example, which we can, something to start with. Like I told you, I'm a farmer. And one of the things I do is to cut grass for my cows. And I'm doing that during that season. Sometimes we have to do it 3 times a day. Take a truck, go to where the grass is, and bring them. Why should we be doing that? What's wrong with covenant? And the grass is all available here, abundant. It's a big deal for PPD to keep up. Why can't we have Covenant University come up with a system of cutting, shredding, baling, and forming hay, which can be sold to farmers? I even assure you, I will buy all that you can produce. On that note, ladies and gentlemen, I want to say we all have a role to play. So let's all join together and begin to find solutions to solve Nigeria's problems. God bless you. Thank you very much.
Thank you very much. You may please be seated. Thank you very much. At this point, I'd like to invite to move the vote of thanks for this very special event, the Deputy Vice Chancellor of Covenant University. Please, would you put your hands together for Professor Olujide Adekeye?
Chancellor, sir. Starting on the existing protocols, I wish to move this vote of thanks on the behalf of management, Senate, faculty, staff, and students of Covenant. The Chancellor and Chair, Board of Regents, Covenant University, Dr. David O. Oyedepo, ably represented by Pastor Niyi Bicroft. Thank you for gracing this occasion. This has been an impactful and insightful lecture on sustainable energy and production technology, Panacea for the development we want. Congratulations, sir, to the lecturer of the day for a well-delivered inaugural lecture. I thank all of our special guests, sir, who are here, present physically, and those who are connected online for being part of the 30th Inaugural Lecture of Covenant. I want to thank and equally appreciate all members of the Covenant University community, talking about the management, members of the Senate, faculty, staff, and students of Hebron. Members of the press here present are also acknowledged. Lastly, I want to thank and appreciate Dr. Mrs. Ajayi and other members of the Oluseyi Ajayi family, and congratulate you all on the success of today's lecture. May I respectfully request that we put our hands together for the Almighty God who made this day a success. Thank you. To him alone be all the glory, and I wish you all safe trip back to your various destinations. Thank you and good evening.
Thank you very much, the Deputy Vice Chancellor of Covenant University. Please listen to the announcement for the 30th Inaugural Lecture of Covenant University. I want to begin with acknowledgement of some distinguished guests we have right here. I'd like to acknowledge His Royal Highness, Oba Rafiu Oyekomi Osobeleje. You're welcome, sir. And our Royal Highness, you're welcome too. Thank you very much. I have right here present Deputy Vice Chancellor of Bells University of Technology, OTA, Professor Pearl Opoko. Please let's put our hands together in appreciation. I want to acknowledge the former Deputy Vice Chancellor, Federal University of Agriculture, Abeokuta, Professor Muftau Adekojo Wahid. Thank you very much. We appreciate you. We have right here, I want to acknowledge all former chapter chairmen, Nigerian Society of Engineers. Thank you so much. We're happy you're here. Please let's put our hands together for them. We also have former national and all former chapter chairmen of the Nigerian Institution of Mechanical Engineers. Thank you so much. Again, we appreciate you. And all our other distinguished personalities that are here, we appreciate every single one of you. The Deputy Vice Chancellor has extended thanks already. Please, I'd like to announce that all university guests, and of course the guests of the lecturer today, members of Senate and members of university management, will be entertained at the Center for Learning Resources facility that is directly opposite the chapel. So please, once we're done, you can just proceed there. The lecturer would also want to let faculty and staff know that they can proceed to the Department of Mechanical Engineering after this event. Thank you so much. So we appreciate everyone, and we believe that you have been refreshed today, and we know that it has been a wonderful experience. So please, would you put your hands together for yourselves again? We started this program with prayer, and definitely we will conclude with prayer, because you will agree with me that God has done a wonderful thing for us today. Please, can we rise as I invite the chaplain of Covenant University to please come and lead the closing prayer of this event.
Praise the Lord. Shall we pray? Father, we thank you for the helps that we have received today. Thank you for all that you have done. We acknowledge and we appreciate you for it. Take all of the glory in the name of Jesus. All else that have been put together today, we ask that you take absolute preeminence going forward in the name of Jesus. And for all of us who have come from our respective destinations, our return be safe in Jesus' precious name. Thank you yet again in the name of Jesus Christ. Praise the Lord.
Thank you very much, sir. We'll take the Covenant University anthem as we sign out this event today. The band, please. Please, as we remain standing, the band will continue to play while the Chancellor's procession will exit the building. Please, following the high table immediately, I would request that His Royal Highness and the wife of our lecturer today will please proceed and follow the high table. Can we have members of Senate of Covenant University please join the procession? Immediately after the Senate members, I would ask that the special guests should please follow, starting from the first row right here, and then proceeding. We appreciate the band, CU Band, for doing an excellent job today. We appreciate the studio for their massive support. We appreciate the kings and queens of Hebron. Would you put your hands together for yourselves? Thank you for coming out today to honor our professor today. Thank you very much. God bless you. Immediately our guests are out. You can exit the building too. Thank you so much. God bless you.